Okay. All right, y'all. We're gonna get into this conversation tonight. We're about to tap into our math genius. Tonight is kind of like we're taking a trip through all the ways that we see the pieces of the coordinate plane. So
Cool.
I'm excited to see where the conversation goes tonight, see what we can have an aha moment about and dig a little deeper in. So, you know how I like to start it? I want us to just kind of introduce ourselves for anybody who may come across this, who may not be acquainted with one of us, or all of us. You never know what the reach may be. So, if one of you guys can jump in and let the people know who you are.
Dana Harris. I am a father, a math educator for going on 20 years, and I am the chief academic officer of Young Math Tutoring, which is an online math tutoring service specializing in 6 through 12 mathematics.
All right.
Akil Parker. Wait, how come my screen didn't pop up? Can y'all still see me?
Yes.
Yeah.
See me and hear me? Okay, cool, cool. All right. Akil Parker, CEO and founder of All This Math, where we offer math tutoring and consulting work. We're trying to improve the relationship between mathematics and the Black community. I've been a math teacher for the past 19 years, and I'm a father of three.
Awesome. Awesome. So I am Lanisha, and I am the owner, operator of Bud and Bear Fruit, which is a tutoring services. Start off as a tutoring services, and we're growing and trying to do more with that. But essentially, I'm just helping those students to believe that they can really be great at math. I'm trying to change the mindset that there's a such thing as math people, and that because mom and daddy weren't good at math, I am not good at math either. Trying to change that thought process one session at a time. And during the day, throughout the school year, I am a district math coach in Cumberland County Schools. So I'm excited to be joined by you two, as I always am, because I am able to learn from you guys. And I feel like iron sharpens iron. So, without further ado, we're going to go ahead and jump into it. So, I want us to start off tonight's chat with a math myth buster. So I know you guys have seen it. I know you have seen somebody say something about another day has passed without using y equals mx plus b. If I had $1 for every time I seen it, I don't know how much money I would have, but I know it'd be more than $1. So talk to me about this myth. Talk to me about this myth.
Well, basically, you use it all the time, even if you don't know that you're using it. At least as adults, we definitely do. Whenever somebody is calculating a paycheck, or if we're looking at anything that you know um, has a rate of change. Like even if we go, like every time you say like something is expensive, right? Like how do you know something is? How do you know that you consider something to be expensive? Because the price has increased, or you don't feel that the price is commensurate with what you're receiving for that. So that's really, without you realizing it, you're considering what the unit price should be, or what you think the unit price should be. Because
Mm-hmm.
you're like, yo, that's high. Or even if you say something is cheap, you think it's a good deal.
Mm-hmm.
The unit price is the slope. Why the M and Y equals MX plus B. And then again, like I earlier mentioned, calculating a paycheck, if you work hourly, your hours would be X, your wage would be M. That's your slope again. And Y is what's actually going to be in your paycheck, or at least your gross pay, at least before they take the taxes out and the FICA and the other deductions and whatnot. I don't know, you might get child support pulled out or something like that, but all of that. Now, I'm saying I know about it. I've lived that life. But yeah, but again, so these are ways in which we use Y equals MX plus B. It's all around us. And then even if we're paying for a service, like if you rent like you might rent a car or something from Enterprise, or even if you do like Toro or something, you may get charged a flat fee up front. That would be your Y-intercept. And then you may get charged on a daily basis a certain amount of money, right? So the time frame, like, okay, if it's this much money per day, the number of days would be X, or the number of hours would be X, and M would be the amount that you get charged per day. Or, even like, getting a hotel room. You're paying a certain amount of money per day, per night, you know? So we're using it all the time. And I think, but I do think that most people, when they say that, it's like a response to like frustration, but then sometimes it's a little bit of like arrogance, like, I don't need math anyway, like, because it was difficult for you, or maybe, the teacher didn't. Also, sometimes teachers like me, myself, early in my career, I didn't really understand the connections to everyday life with y equals mx plus b. I was just real heavy into just the textbook says this, how to calculate the slope and how to calculate the y-intercept and how to find it on the graph. And, I didn't really get as deep into the real world applications of it, but nowadays I'm real heavy into that. But, sometimes, people weren't told, how it's applicable. That's part of it too. But yeah, but it's definitely a myth. Definitely a myth, because like we use it, but we don't know we're using it.
Right. Dana, what you got?
Akil said something very important. A lot of the mathematics that we use, people don't realize that they're using it. So at first I was going to say Akil gave all the examples I would use, but one came to mind. As a military brat, we moved around a lot, right? And so you drive around and you may pass a U-Haul spot or a moving company, right? But we'll go with U-Haul for the sake of simplicity. And on the side of that truck, it might say, rent me for $24.99, right? So what they don't tell you is that the flat fee of renting that truck might be $24.99, and it allows you up to a certain amount of miles, right? So they always gonna ask you, okay, well, how many miles are you gonna be using this truck? And then they're gonna say, okay, well, beyond this 50 miles or beyond this 100 miles, you're gonna be charged a rate of, let's say, 75 cents per mile, right? So that flat fee is the $24.99. But if you once you go beyond that allotted number of miles, they're going to charge you. So that flat fee is the y-intercept, or the vertical intercept for the new math language. And then you have the slope, or the rate of change, which is the 75 cents per mile, right? And so your fee that you're going to pay in total is going to increase based upon the number of miles that you use that truck.
Thank you for that example. I'm thinking about one of my Facebook friends who posted this. And when people post it, they know it's gonna get some attention, because people be ready to jump on that bandwagon, like, yeah, you right. And just be typing all kind of stuff. And that day I had time. Like, I typed probably like a whole 2-3 paragraphs of different examples of ways they could use this. And really, the main thing that I wanted them to understand is we just talking about a linear relationship. Like, as one thing happens, something else is happening, right? And them understanding that, and that happens so often in our lives, you're just not paying attention to it. Like, you might not be writing down y equals mx plus b, but you're thinking in that way. You're moving in that way. You're making decisions using that and don't even realize it. So thank you guys so much for all of your examples. So that is really going to be interwoven in some of the things that we're going to discuss tonight. I'm kind of excited, because I'm ready to see where y'all gonna go. So here I got a blank number line. I got a blank number line, a clear slate. Okay. So even before we get to the coordinate plane, I want us to start to think about when students are introduced to number lines. So I know I've been to I've been to California. And in California, in that particular place that I was at, it's escaping me right now for whatever reason. I can't remember where I was at. Anyway, they start using the number line in kindergarten. Oh. Was that same thing? Is that same thing true? Do either of you guys know if that's true in Philadelphia, where you were in California? Dana, do you know if they're using the number line that early?
I'm not sure, because when I was teaching in Cali, I was teaching in middle school. So I'm not sure if they were using it as early as kindergarten, but I would go out on a limb and say that they start using a number line as early as first grade, and absolutely in second grade.
So with them, the main thing was that they're starting with 0. They had number lines all over the classroom, so that students can understand, one more than, one less than, things like that, and see that kind of like in that number line organized in that way. Now, obviously, those early grade levels, they're only focusing on those positive numbers. Then once you get to 6th grade, now we get to see that other side of the number line. So I'm just going to add some numbers up here because I really want to understand from you guys, what do you think is a challenge if kids in some areas are getting access that early? Why do you think we still have a challenge with using, understanding, operating with the number line, even in middle school and high school?
I think one of the reasons is because as you were writing those numbers and you mentioned that it starts in kindergarten, I would love, are you able to copy that number line and do it, make a copy of it above it or below it?
Sure. Well, not
And
with this, but I can draw it.
if not, it's fine, right?
What me do?
For the sake of context, right?
Okay.
So if we put those same lines up there, right, and it's a blank number line, right?
Mhm.
What students have to understand is that because the number system is infinite in both directions,
Mhm.
even if you would have started with that first line on the far left that you're drawing now, right? If you put a 0 right there and go in the positive direction,
Mhm.
every number line is just a piece of the entire number system taken out and put on paper for you. You see what I'm saying? So
Yes.
we could go take a piece of this number line and go from -25 to -5. We could take a piece of this number line and go from 17 to 100. So that's one of the things, and part of understanding that is those arrows aren't there to just make it look cute. Those
Right.
arrows on the right and the left side are to remind us that the numbers keep going. The pattern keeps going in the same way on the right side, and the pattern keeps going in the same way on the left side.
That's a good point. Now, I don't know all of the standards in elementary school, but one thing that I'm seeing is the spacing piece of it. Like when the students would draw their number lines, if you don't give them gridded paper, ain't no telling what you about to get. There's no telling.
Absolutely.
Because they don't understand that whatever my scale is, that
Mhm.
should be an equivalent. It should be an equal space between each of those, like those intervals. The students aren't really, that's not really clicking per se. And even when you say that this continues on infinitely, and I can cut out this segment and choose to focus on this, another piece is the zooming in or the zooming out of the number line. Like I'm counting by 1 here, but I could count by 5 or 20 or whatever.
Yeah.
But that becomes a challenge because now kids are expecting it to be 1, and if they're not paying attention to those scales, sometimes that's how they end up making those mistakes. What did you want to add, Akil?
And I think a good resource to add to that can be rulers. That's a great example of it.
Yeah.
Yeah, one thing that I would add on to this is when Dana, you was talking about the arrows and not just there to make it look cute. That's a connection to geometry. Because when we
Yep.
think about lines,
Mhm.
like how do we know when we identify a line, it extends in both directions, in infinite directions in both ways, as opposed to a segment which starts at one point, ends at one point, or a ray starts at one point and goes on forever just in one direction. So that's definitely something that came to mind about the geometry. But yeah, scale is key. Scale is key. And because you could be going by 2s, you could be going by 3s, you could be going by 4s, and also like that's a decision that students have to make when they get to the point where they have to graph equations and they got to draw their own XY planes, and they got to sit there and think like, okay, well, what's my data? What are my points? Because if I got a point at like, you know, if one of my points is like 100 comma 28, then I don't think I should, then you got to know, okay, well, I probably shouldn't go by 1s,
Right.
but that's another
Right.
skill in and of itself just to know. But again, like usually you are going to go by 1s. And, in my experience, most of the time you go by 1s, but you don't always have to. And I'm not as well versed with the graphing calculator as I should be, but I know with the graphing calculator, I remember like in my experience as a high school student, like I had teachers that were very big on like go into mode and go to the scale feature, change the scale and whatnot. So then that's another thing too, like using the technology to help you with the scale to kind of
Right.
understand like how you do that.
Right. One
yeah,
thing that is becoming more and more apparent with these summer camps is the amount of time that kids need to sit with something. Like a lot of times I feel like whenever we have kids graphing things, at least in my experience, you'll see people saying, or teachers telling students, okay, you need to do this. Go ahead and scale it by this, because you're trying to speed the time up. You don't want to take as much time to spend on giving them an opportunity to figure out, well, what makes the most sense? Like, what should I be counting by? And obviously, I mean, we fighting against the clock because we don't have a lot of time. We talked about that in one of our previous sessions where we have all these standards that we have to cover, and we don't have a lot of time. Sometimes as few as 45 minutes, maybe 90 minutes. But I mean, when you have varying performance levels, you know, that time gets eaten up really quickly, but you trying to differentiate and meet people where they are. So I think that kids need more time to sit with stuff so they can figure out, why does it make sense for me not to be counting by one if the x is 100? Like,
yeah.
why would I not count by ones? Like, thinking about that. So I think we sacrifice a lot of good thinking time or critical thinking opportunities for students because of that race against time.
It takes away the chance for the aha moment
Right,
on the part of the student a lot of
right.
times.
I'm
Because
trying to
they'll,
figure out, how do we combat that though? Like, because I mean, the race against time is not going to necessarily, it ain't gonna go nowhere. So I think, we talked
yeah,
about the parents empowering themselves and becoming armed with, learning these different things. I just feel like it seems like a long road ahead, I guess. Like, it's not going to be an immediate change.
right.
Um, yeah, yeah.
That's challenging too because I've been doing good by not ranting, but that's challenging because on the teacher side of things, there's pacing guides, right?
Yeah.
On
Yeah.
the side of things, I always make the joke and say it would be lovely if kids had a bubble above their head so we could really know what they're thinking. And so that's why it's important for parents to encourage their children to think out loud. It's kind of like when we start out young kids reading out loud. When they're learning how to read, we have them read out loud, right? And then as they go on into the years of school, then they're forced to read in silence, right? And I think that sometimes that kind of stunts their growth, but it has to be practiced at home, right? And so when we look at situations like that, I think it's very, very important for parents to remind students how important it is to be able to take what their thought process is
Mhm.
and put words and or pictures to it.
Yeah. Yeah, and we were talking about that before, like incorporating more activities where students have to show some type of representation of their thinking and getting more into those visuals and things like that. I feel like it's super, super key. Now what I want us to do though, and I'm glad you told me to draw this other number line, because like I said, in kindergarten, in some states they are seeing the number line as early as kindergarten, but they're seeing it from the 0 on. Then once we get to 6th grade, now we're seeing that, okay, we got more than just these positive numbers. Now we have these negative numbers. Now, even before we get to the actual coordinate plane, we have this. So I remember talking to somebody one time and I was like, the double number line is just like the X and Y just on top of each other, right? And they was like, I never thought about that. And I was like, yeah. So like when kids are starting to get into those ratios and they're comparing quantities, like let's say I was trying to make, I don't know, a shade of purple. What colors do I need to make purple? Red and blue?
Yeah.
Yeah,
Okay, so let's say I'm gonna do a proportional relationship. So let's say for
Is it blue
every
and
two,
green? Which red and blue? Is
it's
it
red
red
and
and
blue,
blue?
right?
Yeah, yeah, yeah,
yeah,
yeah.
it's red and
Okay.
blue.
You stumped me for a second for that one. I was like, wait, hold up. I saw red and immediately thought yellow.
So let's say that for every 2 cups of red paint, I'm gonna use 3 cups of blue paint. So now we're gonna get into our scale. So I'm gonna go ahead and scale mine out. If I make a mistake, y'all let me know. Okay, so now the student just went from a single number line where we might have been, talking about the relationship between numbers. We might have been plotting points. We might have been talking about, once I get to sixth grade, might have been talking about absolute value, might have been talking about temperature. Now we start to talk about ratios and comparing the relationships between numbers. One of the things that I've seen students struggle with is, we already talked about the scale piece, but just understanding that this relationship is reciprocal. So sometimes people are stuck with, I have to put this on top and this on the bottom. Which one goes on top? Instead of kind of thinking it through and thinking about what's the impact if I were to put the blue on top versus the red on top. So I want to hear from you guys. What do you think about, students being rigid, I guess, in their thinking and wanting to know, tell me what exactly which one goes on top, versus giving them time and space to kind of think through what makes sense and what's the impact of whichever one is on top or bottom.
I think one, it requires a deeper level of understanding for the teacher. And sometimes as a teacher, as you get better and grow in your practice, you realize moments where you don't give them as much, right? It's kind of like raising a child, right? As a child gets older, you start out having to spoon feed a baby, right? But eventually, when they get about, a few months old, they start utilizing their hands and they realize they can pick things up and that kind of stuff, right? So there becomes a point in time where you can just give them the food, give them the spoon, and let's say if it's oatmeal, and they can scoop it in their mouth by themselves. So they understand the hand-eye coordination. Well, how does that relate to the mathematics? Understanding that even if we put the blue on top and the red on bottom, the ratio of red to blue is the same as the ratio of blue to red. And so you mentioned the term reciprocal. And so for those that may not understand what reciprocal is, yes, the simple way is, when people think about reciprocal, a lot of times they think fractions, right? And so we say we flip that fraction. So the numerator becomes the denominator becomes the numerator. But another term we can use in this case is the commutative property. You see what I'm saying? So it's still going to be the same ratio like you just wrote up there. The ratio of red to blue and the ratio of blue to red, although the numbers are rearranged, once we switch and put the blue first and the red second, we have to take the value that coincides with blue and the value that coincides with red and switch them around. I think that's also something that kids often aren't aware of, even when we start talking about inequalities. So in this case, as long as the ratio is correct and you put the correct value with the correct item that it represents, we can flip them back and forth and it'll still be equivalent.
This just made me think of something as I was writing the ratios up there. Like when you start to get into like the unit rate and talking about the reciprocal relationship, they start talking about that in sixth grade, like understanding that there are 2 unit rates that exist within a relationship. So if a student was looking at the red to blue and I got a 2 to a 3, understanding what type of number would I have to be multiplying 2 times to get the 3? And then what type of number would I have to multiply the 3 times to get the 2? You know what I mean? In terms of like greater than 1 or less than 1 type thing. And a lot of students, they get stuck with that. They really get stuck with that. Even though like when you're looking at it, you think about it, and I know they start to talk about this early in elementary. I don't know the grade level, but when they start talking about fractions, like why, if I multiply this times 2/3, why is the product smaller than what we started with? Things like that. But the students still in middle school are having difficulty with that. What are y'all thoughts?
Well, I got a question too for you.
Yeah.
What is the difference in a scaffolded version of this? Because I like what you talked about. We as mathematicians understand that in order to go from 2 to 3, because 3 is larger than 2, I have to multiply it by a number larger than 1, because 2 times 1 is 2. But in order to go from 3 to 2, I have to multiply it by a number that's smaller than 1, or to be more specific, between 0 and 1. You know what I'm saying?
Mhm.
So now if I multiply it by a number between 0 and 1, then now that we know 3 times 1 is 3. So in order to multiply 3 by something to get 2, I've got to multiply it by either a fraction or a decimal that is between 0 and 1.
So one thing, I love the fact that you said between 0 and 1, because this right here gets into the scale with the scale copies in 7th grade, and it's another concept as well. And I'm glad you said between 0 and 1. I think it's dilations.
Yes.
They were talking about
8th grade.
8th grade. So
Well, yeah.
I was talking to one of the specialists, and I said, I really feel like we need to be clear that we talking about between 0 and 1, because there could be a factor that is less than 0, and then it flipped that joker all the way over. But if we say 0 and 1, and the kids feel like this is the only, if we say less than 1, excuse me, if we say less than 1 and kids feel like it could be any number, versus us being a little bit more specific when they get to those higher levels, I feel like it can be confusing.
That's important, because the person, when we don't say between 0 and 1, that student has a higher level of number sense, because they understand, oh, it's an infinite amount of numbers that's less than 1.
Right.
Yeah.
Exactly. And then to answer your question, you said the scaffolding piece. I think exactly what you said is how I would scaffold it. Like, I would set up an expression showing them 2 times 1 gives you what, 3 times 1 gives you what. But we're trying to get to this. So now where does that fall in our list? That's exactly what I would do. I think I might have did that this week sometime, but that's exactly what I would do. Okay. All right. So we started in kindergarten with the number line from 0 on up to 20. Then we got to 6th grade, and now we got our positive numbers on the right. We got our negative numbers on the left. We started talking about ratios. We went into double number lines. Now we getting ready to go into our coordinate plane.
Can I interject something?
Yeah, absolutely.
I think this is also a great example of why even elementary school teachers, the ones that want to teach, they like children, they want to make a positive contribution to the community, but they are uncomfortable with math generally. They have to get comfortable with math, because like this whole conversation right here, whereas this is you might be teaching 1st grade or 2nd grade and trying to teach the number line, but knowing that one day when the child is gonna be in, I don't know, 10th grade, 9th grade, 10th grade, graphing parabolas, and they want to do the transformations, and they start out with the parent function y equals x squared, and then you say, okay, well, if a, and then you get into the whole, all right, standard form y equals ax squared plus bx plus c, or vertex form, whatever, y equals a times x minus h squared plus k. That a value is going to determine whether it's going to be a stretch or a compression. It's going to get skinnier or it's going to get wider. And whether it's a fraction, a positive fraction, or a negative fraction, well, if it's a fraction, then it's, see, I always forget this. Like, when it's a fraction, that means it gets fatter, right? Because it's always like the opposite, right? Because I used to think like, well, why would it get fatter if the number is smaller, right? But it's like, it's because it's affecting the y value, right? So it stretches, right? But just knowing that, it's like, if I'm teaching 2nd grade, I would hope to be teaching 2nd grade with the thought that, okay, one day this child is going to be in the 10th grade.
Right.
So while I'm teaching them these basic fundamentals, I'm teaching them with the thought that, okay, I want them to understand this. And I may include those details, because a lot of people just chalk it up and just are like, well, they don't need to know all that right now. But even if they don't necessarily need to know it fully right now, at least there's ways you can introduce those concepts at a very early age, because you know that that's not even the end goal, but that's a goal for down the line years later.
So, question for you: when you were talking about the fraction, you talking about if it's a proper fraction, right?
Well, yeah, because if it's improper, then it's going to be more than 1 anyway. So yeah, between 0 and 1. Yeah, so a number between 0 and 1.
So then, so when you were saying that, in my mind, I was processing, okay, if it's a if it's a proper fraction, that means the amount that I'm going to, I know we're talking about parabolas, but stay with me for a minute. The amount that I'm going to rise is going to be less than the amount that I'm going to run. So it seems like it's going to decrease the steepness. It's going to make it less steep, if that makes sense, which in turn, if I'm talking about a parabola, makes it go like this. I think I'm thinking about like a.
Yeah, it like it
I
gets
like that. Yeah, that's a great. Yeah, I like that, niece. That
Yeah.
I never thought about it like that.
Okay. I just want to make sure I won't trip. Okay.
And I like also to add on to Akil's point,
Mhm.
it leaves the door open for future learning. I love the fact that you jumped all the way to high school, but let's just jump from first grade to fourth grade. You know what I'm saying? Like we have to leave that door open because too often in our generation, teachers said, you can't do that.
Mhm.
And what about, especially in this generation of kids where they're extremely literal? Yo, when you tell them they can't do nothing, do something, they it's stuck in their brain, unfortunately, a lot of times. And so then now it's difficult for them to comprehend the concept of negative numbers because they said, well, 5 minus 7, you can't take away 7 from 5. So
Right.
vertical language is extremely important, which now means going into your field, Akil, I think it's so imperative that when you teach a class like a methods class for teachers, it's so important because if they don't take that class or if they don't have an understanding about how important the language is, then now the vertical alignment of the language shifts. I know I've said things in regard to different grade levels that I've taught. I know I've said things at times that may not have been vertically aligned with the next grade. But as I began to understand how important that was, I slow down a lot more now and I'm mindful. I might say, oh, such and such and such. Well, yet. It's kind of like in my class, I always say, you can't say I don't know. You got to say I don't know yet. So we leave that door of learning open for a child down the line, and they don't think that there's just this brick wall that you can't go beyond.
Absolutely. I'm glad you brought that up because I don't know the statistics on it, but I know that it takes some time to get a student to unlearn something that they've learned. So if I learn to do this and I feel like whatever my teacher has taught me is, what do they call it? It's one of those it's a rule that expires. If a teacher has taught me something that expires and now I get to a grade level where I'm beyond, like when they say you can't take this larger number from the small number, but now I'm in 6th grade and now I'm getting into the negatives. Okay, it's going to take me a while to get through to you because now you got to kind of unlearn the fact that your teacher told you can't do that. And then when we talk about the fact that when we're stacking numbers, we can actually even incorporate the negative numbers there. Like it's so much that I feel like is out there for us to do that probably when we were in school, it wasn't possible. But now we're realizing over time and experimentation, exploration, that so much more is possible than what we had initially thought was. You know what I mean? So just being careful, like you said, what we say to kids, but I think that takes understanding what's coming next. So that goes back to what Akil was saying, is even those early elementary teachers are going to have to be at least somewhat knowledgeable of what comes after them. So you're not saying something that expires.
Yeah. And even it affects my practice. Like even like when I started, I got down with NAM, the National Association of Mathematicians. So I'm hanging out with like math PhDs and people that have taken a lot more math classes than I have. And because honestly, truth be told, like the highest math class I've actually taken that I have on my transcript is Calculus 1. I took Calculus 1, and then and then that was a general Calc 1 class. But then when I ended up at another school, I took calculus for non-science majors because I was a business major. So I never took Calc 2, I never took Calc 3, never took differential equations. I want to take those classes going forward, but it makes me think, like, I'd be like, damn, like I often wonder, like, things that I tell people when I'm instructing them in geometry or like, pre-calculus. I'm like, damn, like I wonder if somebody that is well versed in commutative algebra would come in and listen to what I'm telling this student, if they would say, well, actually, You know what I'm saying? Like, we actually can divide by 0, but there's a special case, and we call it this, and then we have I don't know, because I was thinking about that more recently too, because I was watching I watched Joe Rogan had Terrence Howard on again, except now he had this like mathematical physicist on there. So we had the mathematical physicist on there. So the physicist was like kind of breaking down, in a respectful way. He was breaking down like Terrence Howard's thoughts, and he was kind of telling them like, yo, like, okay, so when you say this, actually what you're saying, you're missing this, or you're leaving this part out, you're forgetting about this and whatnot. And, so he made some comments about things that we generally accept as the mathematical physicist made some comments about things we generally accept as like, okay, well, we don't do that, or that's undefined or whatnot. And, it reminded me like, I wonder like, because as you get to these successively higher levels, sometimes you can do certain things, or things are, it just, it's how like the rules kind of expand, you
Yeah.
know, for like what we call something. I can't remember the example, but one day, like last year sometime, I was asking people about composite numbers, and I was like, well, I think I was asking like, is 0 a composite number? Because a composite number has more than 2 factors, but isn't like 0? I don't know. I don't think that was the question, but it was something related to that. And then people came in and correct and told me like, no, it's not, because whatever it was I asked, they were like, no. But then I was thinking about what the general definition of like a composite number has more than 2 factors. Prime number has exactly 2 factors, but then that definition doesn't get into the specifics of the nature of those factors.
Hmm.
And then so that's when it opens up the door for, more detail.
I love that because I like to brag and tell kids I forgot more mathematics than you've ever learned. And they looking like, why you bragging? Like, and I had to change up the way that I say it, because as a math major, it's somewhere behind me. As a math major, when I got beyond, I can't remember what class it was, right? But it was a class that we got into proving those types of things, right? And it was so cool because although it was extremely difficult at the time when I was taking those classes, we really got into proving mathematically some of those things. And it's really, 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 really cool. So what I like now is that even with learning the language of, um, I always got to throw my quotes up, new math. Learning the language of new math is cool to me because I'm like, these things already existed. It's just the way that our system has been set up here in America. They didn't go in depth with those things. And I think also that stuff is important because, like you said, there's a level of mathematics certain people don't know. So that's why they're not going to be able. That's why they're going to say something as concrete when it's really not.
Right.
And I think that that's important to have those different conversations. The other piece too is that when talking to someone that is knowledgeable about those really high levels of mathematics, I think it's important to do it with someone that has good communication skills, because
Yeah.
they'll make you mad, because you'll feel like they're talking down on you. You know what I'm saying? It's like, wait, nah, I just wasn't aware of it. And then sometimes those people, I've seen some brilliant mathematicians that know the mathematics, they can do the mathematics,
Mhm.
but as far as breaking it down at the teachable level and breaking it down into chunks,
Yeah.
they do a horrific job of that.
Yeah. 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 Um, I had so many thoughts. I don't even know where to start. Um, I'll figure it out later. So we talked about the kindergarten, we talked about the progression. So now we at the coordinate plane. So what is it that students need to be able to know and understand about the coordinate plane?
Mm.
While y'all thinking, one of my Jamaican teachers, she said, they call it the Cartesian plane. So when we were saying the coordinate plane, she was like, huh? And I was like, yeah. So that was instead she was using the language Cartesian plane, and the students was like, what you talking about? Like, huh? What? Or, like they were legit lost. But yeah. So that I just thought about that. So what is it that students need to know and be able to understand about this plane?
One thing that comes to mind to me, and I want to stay focused on the topic, but one thing that comes to mind to me is when we connect this vertical and horizontal number line like this, I'm going to go out on a limb and say 100% of the time, the intervals have to be the same for the vertical number line and the horizontal number line. What I've found that confuses some of the students these days is that when they get into the higher levels of mathematics, 7th grade, 8th grade, high school level, once we take away, so we got 4 quadrants here. Like, okay, so there we go. So first, to answer your question, you got 4 quadrants. What do I mean by quadrants? Quad meaning 4, so it's 4 sections. And it goes like, I love the fact that you're doing it like that. It's always written in Roman numerals. It goes top right and it goes counterclockwise. And the intervals have to be the same. But what is challenging for kids is when we give them problems to where we only show the first quadrant. Now, based upon the 2 values that we are comparing, right, on the x-axis and the y-axis, now you have things that are problems that are being presented to kids to where the scale on the x-axis might be in 5s, the scale on the y-axis might be in 20s. And so they need to understand that whenever you see it like this, the intervals should always be the same. They also should understand, just like we said previously, those numbers, if I tell you to graph, let's see, 1, 2, 3, we got 5. So we got positive 5 on the x-axis, negative 5 on the x-axis, positive 5 on the y-axis, negative 5 on the y-axis, right? But that does not mean that positive 10 on the y-axis and positive 10 on the x-axis is not there. You just don't see it. So I think it's important for them to understand this is, once again, a screenshot, if you will, of the x and y axis intersecting.
Okay. All right. What else they need to know?
Every point has 2 coordinates.
Okay.
And that's if we 2-dimensional. So again, that
Right.
because so okay, I'm glad I said that, because I often think to myself when I find myself saying that, if I was to say that every point, if I was to definitively say every point has 2 coordinates, that's actually wrong, because it's not limited to that. Because what if we go in 3D with it? What if we gotta, it could be 3-dimensional? But it's like it's like when you say it, it's like, okay, for our purposes, for this 2-dimensional, we got an x-axis and a y-axis, right? So these points have 2 points, but even that is kind of, it gets confusing for students, because they're like, okay, it's 1 point, so why don't I have one number? Like, because they'll say, okay, well, if the coordinates were like 5, 3, okay, I found 5 on the x-axis and I draw the point at 5 because you said it's 5. But it's, students have to understand the relationship between those 2 coordinates, like where they meet. I remember when I first started teaching years ago, and I started thinking back, like, damn, how can I explain this? And I started thinking about the old game Battleship that was out in the 80s. But then I was like, man, like, they don't know nothing about Battleship, so I can't even use that as a reference. But I was just thinking, like, man, if they was playing if they played Battleship, because that's all Battleship is. You gotta use the coordinate plane. And you got X coordinates and Y coordinates. And that's one thing that comes to mind. So you got to know how to plot points. And
Before
that's
you
one of
go
those things
deeper,
that,
I want to say something real quick.
yeah.
You said something about, if we say that this point only has these 2 coordinates, then we are not correct. So I'm going to add in that us saying plane means it is 2-dimensional. So then that means we only going to have the X and the Y.
I like that.
Okay.
Because he was saying that, because I never thought about that piece, Nisha, and I never thought about what you were saying as well, Akil. And I thought about college when I got 2 vectors, and they have that 3rd axis, which is the z-axis.
Right.
That's a whole nother thing. But I love to connect those 2 points with that term plane. And then, okay, so then now, when they introduce the coordinate plane, how much exposure has a child gotten to two-dimensional shapes? And what
So I got this
how are
slide there
they
too.
how are they even if they've talked about shapes? Oh yeah, this is a triangle, this is a rectangle, this is a rhombus, this is a, because they learning the difficult shapes in first grade now.
Right.
But where is the connection? Either in the curriculum or in the teaching, in the lesson. Where is the connection between those two? And I'll go out on a limb and say this to anybody listening to this. The beauty of these conversations is we are having conversations to show y'all how interconnected mathematics is.
Right.
And that's extremely important. It's not all these different concepts that are totally separate from each other. We live in 3 different cities, but we're connected through the World Wide Web and Zoom. You know what I'm saying? I ain't never met a Akil in person. I feel like that's my man 50 grand though in these math streets.
Yeah.
And so I think mathematically that those concepts have to be taught. And one other thing, because to answer your initial question, Nisha, students have to understand you wrote that X and that Y in parentheses, right? So that represents an X coordinate and a Y coordinate. Students have to understand that when you see an ordered pair, the X coordinate is going left and right. So that's your horizontal axis. The Y coordinate is going up and down, your vertical axis. I think that's what trips up a lot of kids. I've seen way too many kids getting into 9th grade and they still are confused about which direction to go first. So I always remind them, everything starts at the origin, 0, 0. So go back to that origin, go back to the center, and then you see that first coordinate. Okay, let's say it's a 2. You need to go to the right 2 units. You see that second coordinate, it's a -4. You need to go down 4 units. So I think a little more foundation has to be given to the students about, number one, direction on a vertical axis by itself and direction on a horizontal axis by itself. So now once you connect those two, they're able to see, oh, okay, well, that's my x-axis. That's that first number. So the positive numbers go to the right. The negative numbers go to the left.
Right.
The second number is my y-coordinate. The positive numbers go up. The negative numbers go down.
Right. So as you guys were talking, I was listening, but I was Googling too. You said something about you wonder how much students know about two-dimensional figures. So I was trying to Google to see at what point do they clearly define what area is. I know they work on finding area in elementary school, if I'm not mistaken. I couldn't find the exact standard that quick, but if they are defining it as the space within a two-dimensional object, then by the time they get to middle school, they should have heard the term two-dimensional. But again, it just depends on what they saying. Because I don't know.
And that's also why it's important for parents to reinforce the learning at home. Like you don't have to be no math expert as a parent to reinforce the learning. Practice.
Right.
Like get some practice with your kid. I know that's difficult sometimes, depending on your family structure. But yeah, you got to practice. And yes, I'm glad you put that up there as well.
Yeah.
So I put this up here because, well, obviously it's one of the things that we need them to know and understand about it. But also some questions that I ask students, because I'll have them to just like notice and wonder about the coordinate plane. Like after we put everything up here that we remember, we recall, whatever. Okay, tell me some things you notice. And hopefully students will start to see that quadrant 1 and quadrant 3 are opposites. And then quadrant 2 and quadrant 4 are also opposites, because that kind of helps us whenever we start to get into things like rotations and things like that, like they understanding that those are opposites. Looking at those signs also lets them know about those opposites as well. So what were you gonna say something else about the coordinate plane?
Yeah, I was. So couple things. So I got three thoughts, 3 comments. Well, 3 comments. The connection, based on your point about all the different subgenres of math connecting. So when you said coordinate plane, Lanisha, that made me think about geometry, definition of a plane, two-dimensional surface that extends on forever in all directions. So then that ties in with how the x-axis goes on forever in both directions. The y-axis goes on forever in both directions, up and down, north and south, however you want to look at it. And all the points within the quadrants also do the same thing. They go on forever to infinity. And also, another thing I think students should understand, because this is something that used to give me trouble as a student. I remember this. When the coordinate plane is introduced and the quadrants get introduced, and then you get the exercise where they give you the worksheet or the textbook page and they plot a bunch of points. And then I'm thinking like, okay, the lesson was about the quadrants. And then they give you the points that are on the x-axis and they give you the points that are on the y-axis. And they say, well, which quadrant is it in? And I'm like, I'm thinking in my mind, I'm like, it's got to be in a quadrant, but which quadrant is it in? And then because the teacher might not have gave me an example where it was like, okay, that's not in no quadrant. It's on the y-axis. So it's not in no quadrant.
Right.
It's on the x-axis. So I'm sitting there thinking it's got to be in one of the four quadrants, but it don't. It's not. It's like, oh, that's like a trick question, like, so they gotta also like understand that as well. And also this makes me think of, a connection to trigonometry. I'm looking at this and I'm thinking, all students take calculus, like ASTC, like, what is it? The angles are, but the trig ratios are all of them are positive in the first quadrant. The sign ratios are positive in the second quadrant. The trig take is in the third, all positive in the third quadrant, and cosine is positive in the fourth quadrant. So I'm thinking about that too. How the coordinate plane is such a building block for so many things later on. But then see, we get back to the point I made earlier about like, because somebody will be like, well, I'm only teaching middle school, so I don't need to know trig because I'm just introducing the coordinate plane. But it's
Right.
nice if you are, while you're introducing the coordinate plane, you could just throw that in there, like, because when y'all get the trig, when you're in 10th grade or 11th grade, you're gonna need to know this, and just even if you just plant that seed, it's like it's nice to be able to do that, even if
Yeah.
you don't go into the whole lesson. But I'm just a big advocate for like people that are responsible for teaching math to know more higher level math. And I say that as it's like a self-directed critique as well, because like I mentioned earlier about the higher level math, even beyond differential equations. Like I want to know that because I know that's going to inform and influence how I teach algebra 1. That's going to influence how I teach arithmetic. Because
Right.
I want to be thinking about, okay, well, when you get to this level and we doing this, or when we doing the proofs and whatnot, then now I'm thinking differently about how to add 348 plus 79, because I know it's gonna have some type of impact on it.
Right. I think ultimately, like when we talk about teachers having experience beyond their grade level, I think it's one, so they don't say things that are going to expire, but two, it emphasizes the fact that these things are connected. So like, because you're in third grade, that doesn't mean that the things that you're learning in third grade exist on some type of island. Like they're connected to something. You're going to see this again. And I can't remember who said it. I don't know which one of your pages, somebody said it. Like the more math that you're exposed to, it opens up your career fields. So whether you want to be a mathematician or not, like the more math that you take, that just opens you up for the things that you could do, whether or not that's engineering or whatever it is that you want to do. I just feel like it better prepares you. I can't remember whose page I saw it on, but I feel like that makes sense because if we think about it, at the core of mathematics, it's critical thinking, it's patterns, it's relationships. So the better that I get at being able to see and observe things and problem solve, I'm prepared for anything, really, when you think about it.
Yeah.
So we have a question in the chat. A parent says, knowing that standards vary from state to state, what resources can parents use to help reinforce what their scholars are learning?
Our YouTube channels.
Yeah.
That's one. Those are some resources.
I think also they vary, but they vary. It's not much. It's not a wide margin of variation.
Yeah.
Right.
Mhm.
And that was the whole. Okay, let me go on a sidebar real quick. that was the whole intent for Common Core. Right. We see that because of our politically driven nation, that's not what it's turned out to be. But I would encourage parents to realize that the concepts, the math concepts, they don't really vary. It's how deep that they go into those math concepts and what they want you to do with those math concepts. You see what I'm saying? So when we talk about skills, like math skills, it's not going to be much variation, right? It's what you do, like so you got the standard, which is what they want you to do, and then you got the underlying math skill. You know what I'm saying? In kindergarten, kids have to learn, they want to learn their numbers 1 through 20, I believe. 1 through 2, no, kindergarten 1 through 10. First grade 1 through 20, right? So what's happening is that the standard might say that a student should be able to figure out pairs of numbers that add up to equal 5 and pairs of numbers that add up to equal 10, right? So that would be what the standard says. But in actuality, the skill that's underlying that standard is you want a kid to be able to add.
That was out in the 80s.
Yeah.
But then I was like, man, like they don't know
That's
nothing about
nothing
that,
new.
so I can't even use that as a reference. But I was just thinking, like, man, if they was
Yeah.
My bad, y'all.
Oh, that sounds familiar.
Oh, I thought I was like, wait, hold up. I hear Kill's voice. Is it frozen? But so the thing is to help that parent, right? I as a parent, but so this is my thoughts to help that parent, right? Anisha might disagree with me on this, right?
My bad, y'all.
Oh, I know what you do. Okay, you on Facebook.
I was trying to paste the link so they can look at something, and y'all was talking, and then you was talking, and y'all was competing. My bad. I'm gonna just wait. Go ahead.
So I think that as a parent, focus on the math skill more than the standard. If you, because a lot of kids, teachers should be teaching to the standard. The skill is where you can help your student practice more. I would say give the teacher space to teach the standard. As a parent, teach the skill, reinforce the skill, because when the skill is stronger within the student, then it helps them achieve the standard.
Okay, so I'm a Google queen. So I just Googled how many states follow Common Core standards. Now I know North Carolina does not follow Common Core anymore. We do the standard course of study, but there's 41 states that follow the Common Core. So based on that, we can say that majority of the states follow Common Core. So there is a file that I'm going to share with y'all that will let you see the skill that Dana is talking about. So I got this file from Achieve the Core. I don't know if y'all have ever heard about them, but I happened to find them a few years ago, and they kind of break down. Oh, go ahead.
Quick question.
Yeah.
For those watching, majority is the definition of majority. That's an equation. That's a formula, right? Because it's what, half plus 1? Is that did I remember that correctly? The majority is half plus 1.
I don't know. That's a good question.
I think it is.
I assume that it's more than half.
Yeah, I think it is. I think it's majority.
More than half is the majority to me.
Yeah. So I think the minimum. I remember reading that. I think I remember reading that. I don't think I made that up. So again, just to put that out there real quick, that's a math equation. Like, so half of 50 is 50 states. half of 50 is 25. 25 plus 1 is 26. Once you hit 26 states, that's a majority. So, but I say that because for the people that think that they're bad at math, they use math more frequently than they think. So a lot of times, so many terms that are generally just thrown around in the English language, they're mathematical concepts.
Right.
We don't see it like that, but they really are.
Yeah.
That just came to mind when you said it.
Just like at least.
Yeah.
Another.
Inequality. Inequality.
And one other thing too is, parents, please don't get it twisted. I done taught in North Carolina. I done taught in California. I got a license in both of those states. Humble brag. But what I've discovered, the states that are not using Common Core, including North Carolina, All they did was took Common Core, switched some things around, and it's the same information. They just moving it around in different places. So where you might do this one thing, especially with high school, right? High school, the states that ain't in Common Core from kindergarten through 8th grade, you're doing the same thing pretty much from state to state, right? In high school, all they did was move some things around, change a couple words. It's all the same when you get down to the nitty gritty.
Okay. All right, cool. So yeah, like he said, same thing. Majority of the states following it. So I'm going to share this link to this document that comes from Achieve the Core that goes over the highlights of major works in grades K through 8. They have one for high school, but it's a little more convoluted. It's a little more complex. This one is a little bit more straight to the point so that you can see the specific skills that Dana is talking about. So I'll make sure that I share that in the chat after we finish.
Can you give them a little bit more details on what you mean by the major works?
Oh, sure. For example, when you look at this file, it's color coded. So whatever is a major work of the grade level, for example, kindergarten, some of the major works is knowing your numbers and the count sequence, count to tell the number of objects, compare numbers, understand addition that's putting together. So that's the real focus of the grade level. There's other things that are going to support it. There's other things that they're going to cover, but the real focus, the things that they want to make sure that the kids are proficient in by the time that they leave, are going to be those items that fall up under that major cluster. So again, I'm going to share that link with you guys after we finish tonight so that you have it. Okay. All right. So I brought this slide up, and I know we are a little over our hour, but y'all ain't said you got to go yet. So I'm gonna see what I can get done real quick. Okay. So
I go cooking a little bit.
Okay. Just give me the church finger and I'll wrap it on up. Okay.
Let me know when I want to make a sidebar comment too. Like, let me know when I could do that.
Okay. So all right. So I'm gonna just kind of wrap this up kind of quickly. So when we started tonight, we started with the fact that in kindergarten, students in some states, students are introduced to the number line starting with 0. And then they look at that, they're using that to understand those relationships between those numbers. And then once they get to 6th grade, they're looking at the numbers on the other side of 0, on the left side of 0. They're starting to get into those operations with those positive and negative numbers. They start talking about ratios, which is a relationship between quantities, looking at double number lines. Then the double number lines go from like this to now like this. So we're looking at the quantities that we represent on the x-axis versus the y-axis. We then talked about the coordinate plane and the things that the students need to know about this plane, how to plot those points, what they're going to first, things like that. So the reason why I have this slide up here is because in 6th grade, they start talking about horizontal and vertical distances. And that's the first step before they start to get into, that's in 6th grade. So then when they get to 8th grade, they'll start to get into figuring out the distances of the diagonal lines at that point. And they start to understand the relationship between the distance formula and Pythagorean theorem and how they're related. Some kids still don't understand that connection there, but that's in the progression of these concepts. So I kind of put a little bit of that in there. We can kind of finish this on another night because I don't want you people starving. But yeah, so I think it's a beautiful thing to see how we've gone through several grade levels just focusing on the number line and how it becomes the number lines and how it becomes the coordinate plane, and then how we get into all these geometric concepts, which was going to be on the end of tonight. So we'll definitely follow up with that. Akil, hit us with that sidebar comment that you got.
Well, before the sidebar comment, I was going to say, to your point, like with the number line, I'm a big fan of the number line. Just like, I love it. Like, to this day, I remember in 6th grade when I learned how to add and subtract positive and negative numbers. And I do it most often by just picturing a number line in my head. I play the number line. I'm like, the first number is your starting point. If you add in, you move into the right. If you subtract, you move into the left. And of course, sometimes you gotta simplify it, because if they hit you with the double negatives, 8 minus -2, then it's like, whoa, wait, I thought you said move to the left if it's negative or if you're subtracting, right? So you simplify it, Double negative becomes a positive, so it becomes 8 plus 2. Okay, and then we just doing 8 plus 2. So really, if we're doing that, we don't need the number line for that. But yeah, I'm a big fan of the number line. I'm a heavy advocate. I don't really like a lot of textbooks get into the, take the absolute value or switch the numbers around, and that's cool. But in terms of what I prefer the number line. I prefer to visualize for the addition and subtraction. The sidebar comment I was gonna make.
Wait,
What you
before
want
you
to say?
sidebar, wait, before
Yeah,
you
yeah.
sidebar, pause real quick.
Mhm.
When you said about this 8 plus, the 8 minus a negative, the 8 plus, the reason why I wrote this down is because, like you, I also visualize the number line. The
Mhm.
way that I try really hard to help students understand this, if they understand that adding a negative is the same thing as subtraction,
Right.
now they can relate subtracting a negative as the opposite of that. So when I
Oh,
add a
okay.
negative, if I'm going to the left, then when I subtract the negative, I got to go the opposite direction, which is to the right.
And subtraction by definition is adding the opposite of a number. So when we see 8 minus 5, that's a positive 8 minus a positive 5.
Mhm.
We can, by definition, say positive 8 plus negative 5.
Right.
Once you start understanding those things, it helps. And I'm with y'all too. When I do integers, that's my go-to with teaching it using the number line. Because kids seem to pick it up like that more. And I would love for them to be able to still use the little red and yellow tiles, but I mean or the red and yellow chips.
Right.
But at a certain point, it's got to become concrete.
Right.
Yeah.
And that
yeah.
goes back to understanding your number facts. And something else you said, Akil, kids ain't when you start talking about the absolute value, they don't always know what the absolute value is yet. So we got to understand what they already know in comparison to what we're trying to teach them.
Right.
Yeah. My sidebar was I was thinking about how, like, young people or people like very young children have these like mathematical minds, and they're like making mathematical inferences. And I want parents to, as a parent, if you're not really immersed in math, you might not recognize it, right? But here's a little story. I noticed something in my youngest son. So I got 3 children. My youngest son is 5. His name is Kwame. Probably you might have seen him on the YouTube channel, a couple of videos.
That's my
Yeah. Yeah, that's my guy. So he lives in Baltimore. So I'm in Philly. So I'm co-parenting with his mother across state lines. So I don't see him as frequently as I see my older 2 children. But I'm in Baltimore for the summer, these 5 weeks, running my summer program. So we started this week. So I've been picking him up from daycare every day. Right. So I pick him up on Monday. He's like, hey, Dad, I know fathers can relate, best feeling in the world, coming to daycare, whatever, child sees you. Hey, Dad, best, whatever, that whole thing is great. Tuesday, pick him up, same thing. Wednesday, when I pick him up, he's like, wait a minute, Daddy, why are you picking me up every day? What's going on? So what I realized was, oh, he's recognizing a pattern. He sees a pattern in something that's different. So I'm like, okay, we have to figure out. I have to figure out a way to leverage that, and like, cause I'm thinking, okay, well, I want to do an Instagram reel on that, cause that right there, just him saying that, he's recognizing a pattern, and that's really that's a foundational concept of mathematics. Math is the science of patterns. So once you start to recognize patterns, so anybody that recognizes patterns, you are fundamentally doing math. You're being a math person. When any type of pattern that you recognize, you're being a math person. Yeah. So whether you're my 5-year-old son saying, whoa, Dad's picking me up from school every day, like it's been 3 days. Like the first day, that wasn't a pattern. That's a one-off, right? So I guess even when somebody say that, a one-off, okay, that's mathematical. This day 2, okay, okay, this happened yesterday, it happened again today. By day 3, it's like, wait, something's going on here, right? It's a pattern, right? So if anybody watching this, just, when your children recognize patterns, that's something that we can build on, and there are different ways to build on it. I'm thinking of ways myself, like how can I build on that, with my own child, and get him to see, like, this is mathematical, like so you have a mathematical mind. I think we all do. We all have mathematical minds, but we're just led to believe that we don't because we're not doing the graduate level mathematics, because we associate being a math person with, you know, what's that movie from back in the day, Russell Crowe, A Beautiful Mind? Like we're not doing that type, we're not doing that stuff. So we think we're not doing math, and it doesn't count. So yeah, anybody watching this, I want you to think like when your child recognize patterns, that's or even when you recognize patterns, just know like you're being a math person just by doing that.
I want to add real quick before we wrap that not only is it if you're not able to do those beautiful mind type math where you got the whole board filled up and you on that little ladder that swing from side to side with your green chalkboard, not only do they consider you not a math person if you're not doing it, I think even some people look at you as not being a math person if you can't do it the way they do it. Like if you think about teachers who want you to do it exactly the way they teach it, when they want you to be that robot, and if you're not doing it that way, then it's wrong. I even think some people like that are quick to box you as a person that's not a math person because you're not doing it their way. And I also think that some of the way that we've been taught mathematics years ago was a way to kind of maybe not intentionally box us in, but I think it was boxing us in because it was a comfort level for whoever was teaching us. So I can teach you this because I'm comfortable teaching you this. If I open it up too much and now I'm letting you explore and you coming to me with all these creative things, I might not be prepared. And so now I'm standing up there as the teacher, not knowing how to respond to something that you've created. Now I don't look like the expert that I'm supposed to be. And I think that as teachers, we have to be okay with a student showing us something that we didn't think about. You know what I mean? Like we got to be okay with that. And if you're not, you might need to look within yourself. There's something wrong there. So it's 9:18. So I like for us to kind of wrap it up. I know you already did your sidebar, but if there's anything else that you guys want to leave the people with as we wrap up this conversation where we tapped into this math genius talking about these number lines and their progression to the coordinate plane, leave it to them.
Y'all are cooking, and I want to just kind of leave my final thought in relation to what y'all just talked about. Parents, if you got a child and you sit there and you say, oh, well, you can remember all them song lyrics. If you could do that, then you could do this math. Or you could do this. Guess what? Capitalize on that. I remember there was a point in time where my oldest son, he wanted to read. Every time I took him to Barnes & Noble, he got a comic book. And I used to get frustrated. But I realized that over time, he was able to tell me the story. He could read comic books and the story flowed way better than I could. So I started to capitalize on that, right? So whatever it is that they're interested in, while your son is in that dinosaur phase, let's add some mathematics to it. Have them to count the little things on the back of the Stegosaurus's back. You know what I'm saying? When your son is in that race car phase, have them count, the number of wheels on the car. When your daughter is playing with Barbie dolls, things like that, find a way to take what they like and capitalize on it to incorporate the mathematics in that. So that's my thought. Because it's just there, man. Music, like if they know song lyrics, it's a certain pattern the way they rap it. Even with the mumble rappers, it's still a certain pattern. Build on what they like. Build on their interests.
Yeah, I wholeheartly agree. I want to second everything you said. Just meet your children where they are. Meet your children where they are, and like figure out ways to, make everything into a math lesson.
Absolutely.
But if you really meet them where they are, then it won't feel like a lesson. So I think it'll be less pushback.
That part.
Because they feel like they're just doing something that they already enjoy doing anyway.
Yeah.
But if you get them young, I know that sounds like manipulative and oppressive, but you get them young with something positive, like developing their math skills, developing their appetite for math, then it's even better. Because then, because they're going to be a lot of forces in the society that are gonna work to turn them off to math. So you kind of want to, what is it like? I guess what is it? Vaccinate them against that, or to protect them from that. Because they're gonna get exposed to that.
Tomorrow, Gil. That's the post.
Not the math vaccine.
They're gonna get exposed. They're gonna get exposed to that. It's like an airborne virus. It is. It's an airborne virus. It's out there.
Airborne pathogen.
Yeah. So you want to like get to them early, and establish that foundation so when they run up against that, they'll be less likely to succumb to it. Yeah.
So what I'm hearing from Dana is we got to use what our kids naturally gravitate towards as opportunities to, take it further. Introduce some mathematic conversation with these comic books or cars and things like that. Even when you talk about cars, you can talk about scaling. Because I got one car that's 4 wheels, I got 2 cars. How many wheels you got? So it's an opportunity everywhere in our lives for us to talk mathematically, talk about those patterns. And then, with the kill,
Even
what
on
I'm
their
hearing you say, you said what?
Even on their devices.
Absolutely.
Mhm.
And the kill, what I'm hearing you say is I lost my train of thought just that quick. But I really appreciate what you guys have both shared. I feel like the common thread from all of our sessions together is the fact that the parents have to get more active, have to get more involved, have to take a more active role in the education of their child. And I think it's going to start with you checking your own beliefs. So how do you feel about your abilities with mathematics, with your abilities to see patterns and relationships? Check that first. If you see that it's negative, then we're gonna have to hit Control-Alt-Delete and we're gonna have to start over. Okay, we're gonna have to hit the reboot because it's gonna be hard for you to build that growth mindset in your child if you don't have it within yourself. So again, I appreciate this time to be able to sit down with you guys. Somebody already hit us in the chat and said that they appreciate us coming up here and talking about these things and providing them with these resources. And I'm just glad. I'm glad. I'm glad that people are feeling the benefit of us talking with one another. Obviously, I'm benefiting because I love talking about math and I can do it every day. So for those of you out there who come across this video, drop something in the comments that you took away from our conversation tonight. I will hope that you guys value this time with Akil and Dana just as much as I do. As always, we want you to bud and bear fruit as you jump into all of this math because all of you guys can be young gurus. Until next time, peace.
Deuces.